Okay, so welcome to the video. I guess we're going to continue on. In the previous one, I did a video on angles and triangles and I guess also lines. So you may recall, so here was kind of a little bit of a summary. All right, so what happens when you have adjacent angles, when there's like parallel lines and so on. Supplementary angles, so supplementary just means when two angles add up to 180 degrees. And we also did triangles, and then we talked about interior triangle and then exterior triangle angles and then what the relationships were. So I'll do a link to that video because you should watch it, because otherwise it'll be hard to understand this one. So in this video we're going to talk about angles and basically quadrilaterals, which are just four-sided polygons. And so you have four sides, and we want to now figure out, okay, so what are the relationships within these types of quadrilaterals? And that can be a square, it can be a rectangle, it can be a parallelogram, as you can see, or it can be just a general quadrilateral, right, where there's not necessarily any relationships or symmetry per se. Now, I guess one that might be missing is, I guess a rhombus is a square, which is kind of tilted. But the relationships are the same for all of these. Now, it is actually easy, and most people will know, okay, the relationships, for example, within a square and a rectangle. So, you may remember that in this case, because of the fact that you have a 90-degree angle, that's what makes a square, okay, with equal sides. Then the relationship is, 90, 90, 90, 90. And if you add up all these interior angles, then they come out to 360. And then the same thing obviously will happen for the rectangle. So because again, we just have 90-degree angles. So all of these, okay, so the interior angles sum up to 360 degrees. Now the question is that also the case for, let's say, a parallelogram or just any four-sided polygon, right? Any quadrilateral. And it turns out that the answer is yes, and we can show how this actually happens. Now, if you take a parallelogram, so if you take this right there, it is actually relatively simple to see that the interior angles will sum up to 360 degrees because they're made up of parallel lines. And with parallel lines, because we have these wonderful properties of lines within here, we actually know quite a bit about the angles themselves. So within here, so notice the supplementary one, so whenever you have a C type pattern, it adds up to 180 degrees when you have parallel lines. And here, that basically is saying this right here. So you have this angle A and this angle B. Okay, so that is creating your C pattern. Okay, so that you have, so this would be your C pattern right there. So you know that that will be 180 degree. And you also have that on the opposite side. So if this was C and this was D, then that is another C, except it's in reverse. So you have another 180 degrees, and you can see that that sums up to, okay, so in this case you'll have A plus B plus C plus D is equal to in this case it will be 180 for both, so it will be 360 in total. So that's what you would have there. And that's because we're just using kind of the supplementary angle, so basically that's that. So that's great. Now, in parallelograms, you can actually do a little bit more, again, because of the parallel lines. And so let me erase this right here and point out to you. So for instance, this A and this C actually must be the same. Okay, so these are equal angles. And then the same thing is true for your B and then your D right there. So B and D are also the same. And that, again, comes from the fact of using kind of the supplementary rule for angles. And in this case, what I'm using, and I'll leave that up to you. So as a student, I guess, of this, so notice that here we also have another C, and here we also have another C, right there. So when you use the C this way and this way, okay, you can actually come up with that. So parallelograms are kind of neat, and we know quite a bit about them. Okay, so here let's just write down so that A is equal to C and also B is equal to D. All right, so those are the interior connections that we have. But what about just a general, okay, so if we have just a general quadrilateral, okay, so let's copy this. You would probably assume, and you're correctly assuming, that indeed it's going to give us, okay, the same relationships, okay, for the interior angles. And I'll talk about exterior angles as well. So in this case, we may not really have parallel lines per se anywhere, but we can use the trick of the triangles, because we know that the interior angles of a triangle are equal to 180 degrees. Then you can simply split up your quadrilateral. So notice I can do this, okay, so we can do that, okay, which is going to give us two triangles, or you can do it on the opposite side, okay, in this way, and again it's going to give us two triangles. And because we know, okay, so that the angles, let me call this, let's say, triangle A, and then let's call this triangle B. So we know that triangle A, okay, so when you sum up all the angles within it, are equal to 180 degrees. And then triangle B, okay, when you sum up all of those angles, they also equal to 180 degrees. And so because of that, and notice that here, so this angle and this angle right here, all right, are shared between two triangles. And so here, when we're just summing up all the different angles, so if I would have the triangles on their own, let me color this in. So let's call this, okay, angle A, angle B, angle C. And then of the big triangle A, okay, let's call this D, okay, and E, and then F. So we know, so from the A triangle, so this one right here, so what we know is that D plus E plus F is 180 degrees. And also it is true that A plus B plus C is equal to 180 degrees. But notice that all of these angles basically make up the quadrilateral angles in the interior. So if you add all of these up, so if you're going to take all of these and add them up together, so this one, all right, okay, so that, then you basically have the interior angles of the quadrilateral, okay? And that, when you add those together, well, so that is just like adding up this, which gives us 360 degrees. So the interior angle, so the four angles that you have, just like you have it in a regular square or rectangle or parallelogram, okay, they also equal to 364 general quadrilaterals that you may have. All right, and that's pretty neat. And then from there you can, ask many different questions. But once you know this rule, it's kind of neat. But at least you can see where it's coming from. It's just coming from the fact of just dividing it into triangles. All right. Now, what about your exterior angles? So what if I took, so let me take this back again here. And what if I started talking about, let me copy it. And I started to talk about the exterior angles. All right, so so now let's forget about what we just did, and let's call, okay, so here we have, and let's say we have all of these angles right here. So let's say again, so I'm gonna say A, B, C, D. Typically, what most of the time teachers do, they just label the vertices, right? And then with the vertices, they might label those and then they give you the angles. I don't like doing that because then I have to write, okay, 3 vertices that make up an angle. All right, so I'll just stick to calling the angles with some letter. So we have these 4 angles, A, B, and C. So we have A, we have B, we have C, and then we have D. So those are the ones that we have. And now again, these are interior because they're on the interior portion. Now the exterior ones we would have to extend. So here what we would have is, okay, if we're going along, okay, and we extend these lines. So let's say if we have that, and if I extend it right here, so we have this, all right. So I'm gonna do that. And then here the same thing, I'm gonna just, okay, extend this and extend that. So, and now label them. So let's call this A prime, and that would be the exterior angle. This would be B prime, that's the exterior angle, C prime, and D prime. All right, so those are the exterior angles. They're outside. Now you can draw them in two different ways, right? Because you can extend the lines also in this way. Okay, so if you extend them in this way, so notice I can do that, right? And I can do the same thing here. I can extend it that way here. And from that, okay, so notice that it's basically this right here. So those angles are going to be the same. So notice it's this right here. All right, because if you just extend the lines, you're going to get, okay, that. And if you notice, so from that, then basically what you have is this D is equal to this D right here, right? And then the D prime is equal to D prime here. So how you extend and which one you call the exterior one is up to you. So the exterior angle is either this or it is that. It's just one of them you can use. And now, what is the connection between the exterior angles? Because we just said that the interior angles, A, B, plus C plus D is equal to 360 degrees. And here, can we say anything about, you know, the exterior angles when we add them up? And it turns out we definitely can. And it will turn out that it is also 360 degrees. And that's a question I wonder if someone can answer in the comment. Why? Why is it that it's 360? Because that's the thing in school, right? I mean, this is just grade 9 math, basically. But, you know, if you're just memorizing things, it's good, I guess. You can get the marks. But at the end of the day, you know, the good teachers will kind of force you to try to figure out why. So I'm not going to answer that for you. You know, I would want you to figure out why, and then you can let me know in the comments. All right, so why the exterior angles sum up to 360 degrees. You can just use reasoning to do that. And that's pretty much it, okay, in terms of the connections that I wanted to make between the angles and quadrilaterals. All right, okay, so thanks for watching, and we'll see you in a future video. Okay, bye everybody, take care.